Hello, this is FlippedHarber for Algebra 2. In this video we're going to cover section 5.1, using transformations to graph quadratic functions. The objectives for this lesson are to transform quadratic functions and to describe the effects of the changes in the coefficients of the equation shown. Our outline will start with looking at parent functions, then we'll talk about translations, compressions and stretches, and then reflections. We'll end by looking at some examples. Now here we see our two most basic parent functions. The parent function for a linear function, f of x equals x, and the parent function that we're going to be working with today, f of x equals x squared. So focusing on that bottom parent function, f of x equals x squared, we see a table of values if we plug in the integers from -2 to 2, and we see what the graph should look like. Now, first most basic transformation would be translations. Now you should be used to the idea of translations. You should be well aware about how they are going to move around, but I want to remind you about our rule. Any changes inside the parentheses with the x are horizontal changes, and they move opposite what we would expect. So if we want to move the graph to the right, that's a horizontal change. You'd think that we would want to add to a number to make it bigger to move it to the right, but we actually want to subtract that number to move it to the right. Everything inside happens the opposite that we would expect. If we want to shift the graph straight up, a vertical translation, all we need to do is add a number to the end of the equation. If we want to move it down, a number. Now a reflection is not that useful if we're reflecting across the y-axis, because the quadratic equation creates a parabola that is its own reflection across the y-axis. Now if we shift that over and then reflect it, yeah, that's going to make a change. That's going to look different. But if we just put a negative inside the parentheses to reflect it across the y-axis, it looks exactly the same. If we put a negative outside the parentheses, so that negative is not getting squared, that's the difference here, is the negative on the right side of the screen is not getting squared, so it doesn't go away, then it reflects it across the x-axis and it turns the graph upside down. Now that blue curve is what we refer to as concave up. It opens up. The red one is concave down, or we say that it opens down. Stretches and compressions, we've stretched and compressed equations before. Again, if we want to do a horizontal change, a horizontal stretch or compression, it's going to behave the opposite that we would expect. If we want to horizontally stretch it, we actually need to divide by a number. We see that with that fraction 1 over b. 1 over b basically means divide by b. So if we want to stretch it, we divide by the number. If we want to compress it, we multiply by a number. Now it's the exact opposite on the outside. Things behave the way we would expect on the outside. If we want to do a vertical stretch, we multiply by a number greater than 1. A vertical compression, we would divide by a number. So if we put it all together, this is what we refer to as the quadratic formula in vertex form. The a value, that is the number in front of the parentheses, is going to be a reflection if it's negative, and it's going to be a horizontal stretch or compression. If a is bigger than 1, it's a stretch. If it's smaller than 1, it's a compression. The minus h inside the parentheses is going to be a horizontal translation. If we see x minus a number, it's a shift to the right. If we see x plus a number, it's a shift to the left. The k at the end is a vertical translation. If we see plus k, it's going to move the graph up. If we see minus k at the end, it's going to move the graph down. So let's take a look at a basic quadratic function, f of x equals x squared minus 3. Now we're going to go ahead and make a table of values and plot those values in order to create this graph. So if we plug in -2, we see that we get 1 out, so it creates the point -2, 1. If we plug in the value -1 for x, we get -2 out, so we get the point -1, 2. Then you can see the rest of the table. If we plot those values on the grid line, we can see that it creates a parabola that's been shifted down 3. Now really the reason to talk about translations would be trying to avoid making this table. If we recognize that x squared minus 3 is a shift down, we should be able to draw the graph without making the table. So let's take a look at these 6 functions and talk about what each transformation is going to be. What's the negative in number 2 going to do to the graph? What's the minus 1 in number 3 going to do? What's the plus 7 in number 4 going to do? In number 5, what's the 1/3 inside the parentheses going to do? What about the plus 3 in 6 and the 5 in number 7? Well, we can see that that negative in number 2 reflects it across the x-axis. In 3, it's translated 1 unit right. Remember, minus 1 inside, it's going to move it to the right 1. In number 4, it gets shifted up 7 units. In number 5, that's a horizontal stretch. Because we're dividing by 3, that's a horizontal stretch. And you can see the other 2 transformations. Now let's take the vertex form, which is our a times x minus h squared plus k, and try to write the vertex form for a quadratic that's been shifted 2 units left and 3 units up. Also, let's graph it. Now notice we should be able to graph it without making a table. So if we shift it left 2 units, that means that we have to put plus 2 inside the parentheses. To shift it 3 units up, we have to put a plus 3 at the very end of the equation. And we see our graph. We just take the parabola that we know it looks like and move it 2 units left and 3 units up. Okay, so now it's time for you to try some of these on your own. I'll see you in class, and I'll see you online.